You know, we walk on it, build on it, and grow our entire world from it. But most of the time, we barely give it a second thought. But right there, beneath our feet, is this hidden universe, a living, breathing system that literally makes life on land possible. So in this explainer, we're going to dig deep and uncover the incredible story of soil.
All right, so let's start with a really simple question that gets right to the heart of it. What's the actual difference between soil and dirt? I mean, you've probably used the words interchangeably, right? But here's the thing. It's like the difference between a living body and a pile of dust. Dirt is what you wash off your hands. Soil is what gives us life. Let's break down why.
And the answer, really, is all about perspective. We have to stop thinking of soil as just a substance and start seeing it for what it is, a dynamic, living ecosystem. It's the planet's ultimate crossroads, the one place where solid rock, air, water, and life all come together to build the foundation for pretty much everything that grows.
Think of it like this. You've got solid rock, which provides the skeleton. Then you have the air and water, which are kind of like the breath and the bloodstream. And then you've got all the living things, from tiny microbes to massive trees, and that's the soul. It's this incredible, constant dance between all these elements that transforms dead rock into living soil.
So, where does it all begin? I mean, how do you actually turn a solid mountain into a lush meadow? Well, the whole journey starts with this incredibly slow but totally unstoppable force, the breaking down of rock.
That very first step is a process called weathering. You can think of it as nature's demolition and recycling program all in one. It takes what we call the parent material, the original bedrock, and just starts grinding it down to create the basic building blocks for soil.
Now, this weathering process isn't just one thing. It comes in two main flavors. First, you have physical weathering. This is pretty straightforward. It's like taking a hammer to a big rock and just smashing it into smaller and smaller bits. But then you have chemical weathering, which is a whole different ballgame. This is more like dissolving the rock, fundamentally changing its chemistry.
And this stuff is happening all around us, all the time, often in ways we can't even see. I mean, just picture the sheer brute force of a tree root, slowly but surely wedging its way into a crack and literally prying solid rock apart over decades. At the very same time, you have these tiny organisms like lichens acting like chemical pioneers. They release these weak acids that just dissolve the rock's surface, literally eating it away over time.
What's just wild is the variety of tools nature has in its toolkit for this job. You've got the incredible power of water seeping into a crack, freezing, expanding, and shattering rock from the inside out. You have the simple daily stress of the sun heating a rock and the night cooling it, causing tiny fractures. And all the while, chemistry is quietly at work, with rain and even the oxygen in the air slowly changing the rock's very structure.
Okay, so the rock gets broken down into tiny pieces. But it doesn't just sit there in a pile. Over thousands and thousands of years, with a lot of help from the climate and living things, it starts to organize itself. It forms this complex, layered structure that tells the story of its own history.
You kind of think of this development like a play in 4 acts. Act 1, the solid bedrock just starts to crumble. Act 2, the first pioneers, simple life forms and organic material, show up and start to mix in. Then, in Act 3, a true topsoil layer starts to form. And finally, after centuries or even millennia, you get the grand finale, a mature, fully developed soil with multiple, distinct layers. And what you end up with is what scientists call a soil profile. If you could see a slice of the earth, you'd see these distinct layers, called horizons. They're like the rings of a tree. They tell you the soil's story. And honestly, it kind of looks like a natural layer cake, where every single layer has its own unique flavor and purpose.
Right at the very top, you have the A horizon. This is the good stuff, what we all know and love as topsoil. It's dark, it's rich, and it's absolutely packed with organic material from all the dead leaves and plants. This is the engine room of the soil, the most fertile and biologically active part.
Now, go a little deeper and you hit the B horizon, which we call the subsoil. Think of this layer as a storage unit. As water trickles down from the topsoil, it carries all these dissolved minerals and nutrients with it, and this is where they end up collecting. It's usually a bit lighter in color, and there's a lot less organic stuff going on down here. And if you dig way down, you'll find the C horizon. This is basically soil in the making. It's made up of weathered chunks of rock, and it looks a whole lot like the original bedrock it came from. It's not quite soil yet, but it's not solid rock anymore either. It's that transition zone. But here's the dangerous truth, and this is a really big deal. This masterpiece of nature, This complex system that takes thousands of years to build, it can be completely wiped out in the blink of a geological eye. And the number one threat it faces? Erosion.
And what makes erosion so absolutely devastating is that it's a thief with very expensive taste. Wind and water don't just grab any old dirt. Nope. They steal the best part first, that dark, fertile, life-giving topsoil. Now look, a little bit of erosion is a totally natural process. It happens. The problem is, our activities can throw that natural process into hyperdrive. When we clear land for a farm or a construction site, we're basically rolling out the welcome mat for erosion. We remove the protective plants, and that bare soil becomes a sitting duck, just waiting to be washed or blown away.
And you can actually see this happen with your own two eyes. There's a scientific term for it, turbidity, which is really just a fancy way of saying how cloudy or murky the water is. So the next time you see a brown, muddy river after a big storm, you'll know exactly what you're looking at. That's topsoil. That's life being washed away forever.
So why does protecting this fragile foundation matter so much? I mean, what's the big deal? Well, it goes way beyond just growing our food. Healthy soil plays this heroic and often invisible role in keeping our entire planet healthy, especially when it comes to our water.
Get this, healthy soil is basically a giant living water purification plant. When rain or snowmelt seeps into the ground, it has to pass through all those different horizons we just talked about. And as it does, the layers of sand, clay, and organic matter act like a natural filter, trapping pollutants and cleaning the water before it ever reaches our groundwater.
So the payoff for taking care of our soil is, well, it's immeasurable. We're not just saving dirt. By protecting this living filter, we are guaranteeing cleaner water for ourselves, we're preventing floods, we're nourishing the plants that feed the world, and we're supporting entire ecosystems. It truly is the foundation holding the whole balance of our planet together. Which brings us to a final, pretty critical thought. We've seen how soil is this incredibly precious resource, something that takes thousands of years of nature working in perfect harmony to create. And yet it can all be lost in a single heavy rainstorm. So that leaves us with a really important question, doesn't it? How do we protect the very ground that sustains us